Here's another example of proofs. So two consecutive positive whole numbers. So for example, 3 and 4. When you take the difference of their squares, it equals the sum of the two original numbers. So for example, two consecutive numbers, meaning next to each other, the difference of their squares. So square this, 4 squared would be 16, 3 squared would be 9. Take the difference of the two, so that would be 7. And then the claim is that it will always be the sum of the original two numbers. So let's test it with another one. So, as an example, let's say 9 and 10. The difference of the squares. So square this. The difference would be 100 take away 81. So that would be 19. Now it always equals the sum of the two original numbers. Look, 9 plus 10 is 19. And this will always be true. But how do we know for sure it will always be true? So we have to prove it. So to prove it, two consecutive numbers. Let's just call this k and k plus 1. And then square the two and then take the difference. So remember, it's always the big one take away the small one. So square the two, so k plus 1, square it, and then square the other one, the smaller one, and then take the difference. Difference means one take away the other. So this take away this, and then we have to somehow get to the sum of the two. The sum of the two being k plus the other number, k plus 1. So we want to get from here, somehow use mathematics to get to here. If we can migrate from here to here, then we've shown that it can, when you take the difference of the two squares, it will be the sum of the two original numbers. So we want to get from here to here. So let's try and do this. Hang on. So squaring this, when you square this, it will be, when you square this, it will be this. This times this will be k squared, and then this times this will be k, this times this will be another k, so that would be 2k, and then 1 times 1, that would be 1. And then take away k squared, take away this thing here, k squared. Now simplify this, k squared, so they cancel each other out, leaving you with 2k plus 1. Now here's a clever part. We want to show that this equals the original number plus the other number, k plus 1. So we ultimately want to get to k and then plus k plus 1. Then that really proves that that is the original number plus another number. So the trick is to break this 2k up as k and then plus k and then plus 1. You see, this whole thing here is the same as this. But the good thing is that you can see that this is the first number and this is the second number. So we've just proved that the difference of the squares always equals the sum of the two original numbers. Okay?